Hi, this is Suchi, and in today's video, I am going to discuss about two methods that will help us create two-dimensional NumPy arrays, and these are two intrinsic methods. So without further delay, let's get started. So first thing is I matrix, and this is done with the help of numpy.eye. So if you look at this array, if you look at this matrix or two-dimensional array, you can observe one thing, that this is having 1 at the diagonal positions. So the diagonal elements are 1 and all other elements are zeros. So here you can see all other elements are nothing but zeros. So this kind of matrix are called I matrix, NumPy I matrix. And to create this kind of matrix where the diagonal elements will be 1 and the rest of the elements will be zeros, we have this method, which is numpy.eye. So let me clear all of this and let me show you how it works. So let's look at this part, np.eye. So first thing, what is this? As I mentioned, the output of this particular thing will be, as we are expecting, a matrix or a NumPy array, which is two-dimensional. So when there are two dimensions involved, we need to mention how many elements will be there in each dimension. So here we can even consider it as rows and columns. Two dimensions, and the first dimension is rows and the second dimension is columns. And to create this matrix, how many rows are present in this? 3 rows, 1, 2, 3, and the row number will be 0, 1, 2 respectively. Similarly, how many columns are there? 3 columns, 0, 1, 2. So 3 columns and 3 rows. So that's what we need to mention inside this method. So the first parameter is number of rows, the second parameter is number of columns. So here we are saying that create a two-dimensional array, NumPy array, where there will be 3 rows and 3 columns, and the diagonal elements will be 1 and the rest of the elements will be 0. So this will serve that purpose. Similarly, here we are mentioning this is for 4 by 4 matrix. So this will create a NumPy array where there will be 4 rows and 4 columns. Similarly, this will be creating a NumPy array which will be having 5 rows, 5 columns, and all of them will be I matrix. Now let us run this. So here you can see for this 3 by 3, you can see that all the diagonal elements are 1, right? Here you can see all the diagonal elements are 1 and rest of the elements are 0. Similarly, if I move down, here you can see the 4 by 4 matrix. Again, here all the diagonal elements are 1. So here this is the diagonal elements, these are the diagonal elements, and they all are 1 and rest of them are 0. Similarly, here also you can see the same thing applies. So this is doing for the principal diagonal or the main diagonal. So as you can easily see that we are actually adding the same number of rows and same number of columns. So these are nothing but square matrix. But what if this so if it is a square matrix, it is very easy to identify which are the diagonal elements just by looking at it. But if it is not a square matrix, how we will identify which are the diagonal elements? For example, this matrix, not a square matrix, okay? 6 rows and 5 columns. Let me run this. So here you can see this is not a square matrix, but here the diagonal elements are these elements. Here you can see these are the diagonal elements. Okay, these are the diagonal elements. But if you look at it, this also looks like a diagonal element. This also looks like a diagonal, but this is not, because how we can identify the diagonal elements, the main diagonal or the principal diagonal axis, how we can identify that easily? By checking the row number and column number. For example, here, if you look at this, this is the row number 0. This is 1. This is 2. This is 3. This is 4. Okay. This is 5, right? Similarly, these are the row numbers 0, 1, 2, 3, 4. Okay. So in that case, how we will identify the diagonal elements? We can easily do that by connecting this. So wherever the row number and the column numbers are same, that is the diagonal element. For example, if we add this line, here you can see this is the point where it crosses. So this is the diagonal element, 0, 0. Similarly, if we just do this, for the column number 1 and row number 1, here you can see this is the another crossing. This is 1, 1. So this is again another diagonal position. Similarly, this is 2, 2. This is 3, 3. This is 4, 4. That's why these are the diagonal elements. For 5, if there has been another column 5, then we must have one element here which is also a diagonal element and which will be set to 1 in this case. But as we do not have that column, as we have only 5 columns, we do not have the column index 5. That is why we are having only these many diagonal elements. So that is the concept of diagonal elements. So we can easily identify by looking at this. Now, sometimes we might need to have some other diagonal apart from the main diagonal. This is the main diagonal position, but these are the main diagonal positions. But if we want some other one, let's say this one. Okay, let's say this one we want. We want ones in this particular diagonal, not the main diagonal. Or maybe we want this one, or this one, or this one. Okay, or this one, or maybe this one, or this one. So apart from the principal diagonal, if we want any other diagonal, how we can achieve that? So to do that, there is one parameter, that is the k parameter, which will help us to achieve that. So how we can do that? Let me just show you. So if we scroll down, there is this k parameter which we can set to something else. So if here one thing is very important to understand, that is this is the principal diagonal or the main diagonal whose value is 0, and whatever is above this, for example this one or this one or this one or this one, these will be having 1, 2, 3, 4 and so on. So these above diagonals will be having positive value in k, and if we want these below diagonal positions, then we have to add negative value to k or specify negative value to k. So this will be -1, this will be -2, this will be -3 and so on. Okay, so it will go like that. So let me just show you how it is working. If we set the value of k to 0, let's say we are setting the value of k to 0, and we are running this. So you can see, as usual, we have set a 4 by 4 matrix. So as usual, the main diagonal elements are 1 now. If I set k to 1, it will be shifted one position above. So let me show that. Here you can see now what we were expecting. We were expecting this diagonal, and this is becoming 1 now. If we want this one, then we have to, if we want this one, then we have to do what? And we have to set k to 2. Okay. And you can see now it is shifted to this position. And if we set k to 3, then we will be shifting to this diagonal. So let me just run that, and here you can see the result. Now let us look into the negative index as well. Okay. So now let us look into the negative one. So if we wish this one to be 1, this one, what we have to do is we have to set the k value to -1. So let me do that. K value to -1. So now you can see this have become 1. So let me just remove the drawing. Here you can see this has shifted to this diagonal. If we want it to this diagonal, the below one, we can set it to -2. And if we want it to the this diagonal, then we can set it to -3. So this is how it will work. And it will not only work in case of this square matrix, this will be working in case of not square matrix also. Here you can see 6, 5. So if I set it to -1, the principal diagonal would be this one. But if I set to -1, it is shifted to here. If I set to -2, it is again shifted below. So this is how it will work. Now, as you can see here, the data type is float, set to float without, so this is the default value. This is the default data type. But if we wish this to be integer or something else, we can do that with the help of d type. So again, this parameter, if we pass, let me just set it to int, and let us see what happens. Here you can see this is converted to integer. Okay. So we can specify the data type with the help of this d type parameter. So that's all about this eye method. Now let us see another method that will also help us to set diagonal values. But in eye method, we can only set the value 1 and the rest of the values will be 0. But what if we want to specify the value of the main diagonal or any other diagonal elements? Then what we can do? We can use this diag method. So let's say we want to create this kind of matrix where the diagonal elements will have 5, 8, 4 and rest of the elements will be having zeros. Here any other value if we want to add, we can do that, and the dimension also can change. So here for simplicity, I have put a 3 by 3 matrix where the diagonal elements I am specifying and rest of the elements will be 0. So to achieve this kind of thing, what we can do is we can use np.diag. So let me just remove this first of all and let me run this. So here you can see 5, 8, 4, 6. These are the elements I want to put diagonally. Maybe if I want 5, 8, 4 to be set to create this particular example. So what I can do is I can run this, and here you can see the row number and column numbers are taken from the first parameter, which is the array of elements which we want to put in the diagonal positions. So here you can see 5, 8, 4 we have set, and this is creating a diagonal matrix where 5, 8, 4 are set in the main diagonal. And the shape of this array has become 3 by 3. So if we just look at it, look at the shape of it, you can see this is 3 by 3, 3 rows, 3 columns. And this rows and columns, number of rows and columns are decided from this parameter. So the number of elements in this parameter, it is taking as number of rows, number of columns. So we do not need to specify. In case of I method, we are specifying the number of rows and number of columns. But here we cannot, we are not specifying anything such as number of rows or number of columns. It is taken from the length of this particular input. The first parameter's length, it is taking as number of rows as well as number of columns, and it is returning us a square matrix or square array. So if we want to shift this from the main diagonal, and if we want to place this here, okay, place one diagonal above that, what will happen? What should happen? Here we have three values. So definitely it will try to accommodate three values over here. So it will add one more row and one more column. So the shape will get changed. So let me just show you how it works. If we just put the value of k, the value of k is by default 0. It takes a main diagonal. But if I set it to 1, let us look into it, how the shape gets changed. So here you can see this 5, 8, 4 has to be accommodated in this diagonal. That is why the shape is getting changed. And now if I run this, you can see the shape is becoming 4 by 4. If I shift it further, if I shift it at -1, again it will be having 4 by 4. Here you can see this is having 4 by 4. But if I shift it further, like here or here, so if I shift it here, then again this is having two elements, the provision of two elements. So it has to add another row to accommodate these values. And whenever it is adding another row, it will also add another column over here. So that is why if I do that, let me show you. If I do this, if I change this to -2 or 2, then what will happen? It is again adding another column and another row. So the shape is becoming 5 by 5 now. So this is how the diag method works. And it helps us create a diagonal array, a diagonal matrix, which is a two-dimensional NumPy array. So that's it for today, guys. Thank you for watching this video. Keep learning, keep implementing.